Okay, so get this. Today's deep dive is going to take us into like the twilight zone of physics.
Oh, yeah.
Yeah, it's where like time itself gets all bendy, you know?
Okay.
We're diving into this experiment that has everyone talking.
Okay. What is it?
It's called, get this, negative time delay
Negative time delay.
at the quantum level.
Wow.
Yeah, you heard that right. Like, it's practically cause and effect, but they're playing this like cosmic joke, you know? Effects are happening before the stuff that causes them.
I'm trying to wrap my head around this.
Right, I know. And get this, your mission, if you want to accept it, is to like unpack this totally mind-blowing thing with us.
Okay, I'm in. Before we start talking about, like, building time machines and stuff,
Right.
we got to be clear that this isn't some Back to the Future stuff, right?
Right, no hot tubs to the past.
Okay, good.
So, can you like walk us through how this experiment went down? What did scientists actually do to see this negative time delay thing?
Okay, so picture this, a cloud of ultra-cold atoms. We're talking atoms chilled to practically absolute zero, okay?
Wow.
It's like they created this environment where quantum mechanics is king.
So it's like a quantum playground where the usual rules of reality, they just like don't apply.
Exactly. Now, through this cloud, imagine them shining a beam of photons. You know, those tiny little packets of light energy.
Right.
Normally, when a photon hits an atom, it gets absorbed, hangs out for a sec, then it's re-emitted, which creates a tiny delay.
That makes sense. It's like that photon is like checking in with the atom, right?
Yeah.
Having a quick chat and then moving on. Yeah.
Yeah, a super fast chat. But here's where things get really wild, okay? In this experiment, some photons acted like they, totally took a shortcut through time.
What?
They zoomed through that cloud faster than they should. Like, they already knew what was going to happen and found a way to skip it.
Okay, now my brain is like officially hurting. It's like those photons knew the future or something and decided to just cut the line.
That's a great way to put it, honestly. And that basically is like negative time delay. It's not that time itself is going backwards. It's more like those photons are acting like they've already done the whole interaction thing.
Whoa. We are not in Kansas anymore. So like, how does quantum physics even begin to explain that?
All right, so to understand this, we got to go deep into quantum mechanics,
Yeah.
where things get, let's just say, interesting. And to do that, we got to talk about two big ideas,
Yeah.
superposition and entanglement.
Okay. Okay, so superposition entanglement, hit me with it. What are they and how do they play into that whole negative time delay thing?
All right, so superposition first. Imagine a particle, right?
Yeah.
But it's not in just one state. It's like in multiple states all at the same time.
Right.
Like imagine a coin spinning.
Yeah.
Until it lands, it's both heads and tails, right?
Right.
So it's like that, but with a particle. It's in this like blurry state of possibilities until you actually measure it.
So it's not even that we don't know until we look, it's that it's actually in all those states at once. Wild.
Exactly. Now throw entanglement into the mix. This is where two particles get so close, so connected, that their fates are like tied together. No matter how far apart you separate them, it's like they have this invisible string connecting them, and whatever happens to one instantly affects the other.
That's what Einstein called spooky action at a distance, right?
Yeah.
And yeah, it does sound kind of spooky.
Totally. So now think back to those photons, right? Imagine them in their superposition state, but they kind of already know they're about to hit those atoms even before it actually happens.
Wait, are you saying they're getting like a preview of their own future?
It's like they're checking out all the possible paths all at the same time, including the one where they interact with the atoms and get delayed. But because they're in that superposed state, time isn't exactly a straight line for them.
Okay, my brain's hurting a bit, but I think I'm kind of getting it. They're like quantum time travelers, but just dipping their toes in, not like going full Back to the Future.
That's a very poetic way to put it. And this is where entanglement might be playing a part too, you know. If the photons get entangled with the atoms, even for a tiny bit, they could be swapping info about, like, their future states.
And that's how you get that negative time delay.
Exactly. It's not time travel. They're just playing by a different set of rules, the quantum kind. And while it sounds like something out of Star Trek, it actually has some big implications for how we think about time itself.
Okay, now I gotta know. What implications? Does this mean everything we thought about time, like the whole linear thing, is wrong?
It's not that it's wrong. It's more like we've been looking at a tiny piece of a much bigger picture. We experience time in a, big world way where those classical physics rules apply. But at the level of atoms and photons, quantum mechanics takes over.
Two sets of rules for two different sizes of reality.
Exactly. The rules that govern the big stuff don't always apply to the tiny stuff. This
Oh.
experiment is showing us that time, like real time, might be way more complex and mysterious than we ever thought.
So does this mean, like, our whole understanding of time is out the window? Like, should we be digging up Doc Brown and firing up the DeLorean?
Hold your horses. It's not quite time to rewrite the physics textbooks just yet. Yeah. This experiment is seriously cool, don't get me wrong, but it's not like our everyday lives are about to turn into some kind of time warp, you know?
Okay, so my morning coffee is still going to need to be brewed after I turn on the coffee machine.
Exactly. Your coffee maker is safe. For now.
Yeah.
But seriously, it does make you think, right? If things can happen out of order like this, even at a tiny quantum level, what does that really mean for how we understand cause and effect? It's a pretty big deal.
It really is. So where do we go from here? What's the next step in figuring out this whole negative time delay thing?
Well, right now, scientists are working hard to do this experiment again, to make sure it wasn't a fluke. And they're trying it with different quantum systems just to see if those photons are really onto something.
Makes sense. So what's the big hope? Like, could we actually use this negative time delay thing for something?
That's the million-dollar question, isn't it? Imagine, like, quantum computers that could run calculations way faster than anything we've got now. Or what about communication systems that use this negative time delay to send information instantly, even across, like, galaxies?
Okay, now that would be a game changer. Faster than light communication. That's wild.
It is. And honestly, we're just scratching the surface here. This is like opening a door to a whole new universe of possibilities. Who knows what other weird and amazing things we might find when we really start digging into the quantum world.
It's pretty mind-blowing stuff. So for our listeners who've made it this far, what's the one thing you really want them to take away from all of this?
Just this.
Yeah.
The universe is way more bizarre and awesome than we can even imagine. Our everyday experience of time, with all its rules, might just be a tiny part of something much bigger, something we're only just starting to understand.
It's kind of humbling, isn't it, to think that there's still so much out there that we don't know, but that's what makes all of this so exciting. And that's a wrap on another deep dive. We'll catch you next time when we'll be, you guessed it, diving into a whole new scientific mystery. Until then, keep those brains buzzing.